Thank you very much. So my name is Tayeb Bentria. I'm from the Biomimicry Practitioner program, and today I will talk about my biomimicry journey and trying to create self-cleaning solar panels. So as many of you know, I work as a scientist at Qatar Energy and Environment Research Institute. We are trying to tackle three challenges in water, environment, and energy. I work at the material side, so I can support these three challenges. Qatar is here from the satellite. This is satellite image. You can see the dust storm from the space. Uh, so before we start, I want to emphasize on the solar energy revolution in the Gulf countries. The Gulf country didn't actually invest in solar energy until recently. So last year, 24, 25 was a huge investment in solar energy, and this is because it became economically feasible. In the past, oil and gas were so cheap here that it was not relevant, but China did a good job, a great job in automating things, and they break all what they were expecting. So the cost of solar energy now is much cheaper than any other fossil fuel energy. So Qatar, for example, invested in the World Cup this 800 megawatt solar farm to make it net zero World Cup. But currently, last year they commissioned a bigger one, and next year they will double this investment. But with that came challenges. There are not actually many challenges in the desert region because we don't have like hurricanes or strong winds and things like that that can destroy like many environments around the world. But one of the major challenges is dust accumulation. And why it's important? Because this is not like a sand particle on the solar panel. It's actually because most of the cities are in front of the sea. There is a high humidity, and when the dust particle absorb on the solar panels, where it's already have humidity absorbed to it, the dust particle will react with the water and form a cemented layer. So this one cannot be removed by just sniffing, normally. So you need actually to use techniques like here using water to remove this cemented layer, which is not practical in our region because water is a very expensive commodity, especially pure water. And the techniques is used currently is biorobotics. However, your robotics are high maintenance, they require qualified engineers for repair, and they're expensive. These robotics are between $20,000 to $50,000. So our objective is to enhance the solar panel surface to reduce the maintenance time. So instead of cleaning it every week, we try to enhance the maintenance time by reducing it. So here are the negotiable and non-negotiable criteria, which really define which biomimicry principle I use because it's well-defined technology. I'm not building something from the scratch. So in discovery phase, one of the examples is that to go outside to nature and discover how to solve this problem. So I did that, and I found many techniques in the plants kingdom. One of them is using mechanical force. So we have a leaf which form up many leaves, and with the vibration and with the wind, they kind of hit each other gently and remove the dust. Others have like waxy layers, others have hydrophobic surface, other even have some hairy surface that doesn't allow the dust particle to adhere to the surface. And other even change their form. So when there is high temperature or even strong wind, the leaves change, close up, and then they open up when the situation is suitable. In the animal kingdom, there are many examples. I selected two of them. One of them is the elephant. Elephant actually use this use the what they call the dirt to cover to protect itself or to fix the temperature, but it can remove this soiling by having wrinkles on its surface. So one of the ideas I got is that we know that we have some surfaces that they can change their properties when they expose it to UV light, which exists in the solar radiation. So if I have a surface like this, which I found the transparent one. During the day when you have UV light, the roughness of the surface changes, and this lead to cracks in the cemented layer, and it can be easily removed. However, buying the materials, investing in this project actually will take more than 6 months. And I get also to another good idea, which is inspired from the desert beetles, as they can survive in nature for months without any external source of water because they can harvest their own water from humidity and fog. So I went to the abstract design principles. I extracted three design principles. They are here, and the idea is like to have a hydrophilic pumps. Hydrophilics mean love water, so it can harvest water, and hydrophobic background. So there is trade-off between harvesting water and then moving water to the required direction. So we need to have hydrophobic and hydrophilic one, and it's really need deep research to understand the design principles because it's not easy. There is like physics behind it. It depends on the amount of humidity, if there is the speed of the wind, because there is like a trade-off between harvesting energy, water, and using it. Sometimes you can harvest water and then it will evaporate immediately because the droplet is too small. So you need to harvest these droplets and then regroup them to make a bigger droplet. And then you need to have the surface with gravity that make these droplets roll down and fall without being evaporated, because if you evaporate it will create even a worse cemented layer. So there is a research on that. This paper published 2011. They inspired from the desert beetles and the cactus, and they create these triangles. So the tip of the triangle can harvest water, and then it can grow to make a bigger droplet. And when these droplets reach a certain level, they meet together, form bigger droplet, and then jump from the surface, which harvest the water, which can clean the solar panels. However, this technique is created using lithography, the same technique used to create microelectronics, and it's a very expensive one, and is not suitable for this price-sensitive fields of solar panels. So what I did, I want to create a much cheaper one by having these hydrophobic tips generated automatically. So what I did, I coated the surface of the glass with the silicon oxide and 5 nanometer height only. And then I heated the temperature at 500 degrees, which is near the temperature of melting of the glass. So what's happened is that the surface gets cracked, and then the atoms start to get together to form nanoparticles. So now what we have a hydrophilic nanoparticle on hydrophobic surface mimicking this phenomenon. However, it needs a lot of optimization and a lot of trials actually to reach the right concentration on the surface, etc. And yeah, I'm still working on it. We will be using the laser inject printer to have them in certain orientation and certain parts. Not all the solar panel will be covered in this. And there are other methods like self-assembly, copolymers, etc. And yeah, I want also to thank Yuma and Millie for suggesting me to see the Fusion Bionics invention. It's actually a very good one. I think it's better than mine because they are not adding a new material on the surface. They just changing the microstructure of the glass using laser. They have their own patented technique, and they can succeed to change the shape of the glass and having certain pattern that can capture, that can actually create surface, self-cleaning surface. So I contacted them, and they were very kind and wanting to collaborate. And they sent me actually this sample here. You have half of it treated and half untreated. So what I did, I cut it in many pieces, and I'm putting it as an experiment for 1 year in our testing facility. So every 2 months, I will remove one of these glasses, measure the light transmittance, put in under the microscope, check the hydrophobicity change, etc. And we see if this innovation works in our environment or not. We are testing them. Why? Because the dust that they used is really uh, like dust without humidity, and in our case, we have dust mixed with humidity. So we'll test if this will really work in our case or not. So also just last week we approved buying this 3D scanner. I'm really excited about it because you can put your biological sample here and then you can get 3D model with 5 microns precision. The objective of this one actually to use it for feeding the AI model because I'm working also on AI for biomimicry, but I hope uh, that one day I'll be able to extract new biomimicry function using this device. So the key insight and lesson learned from this program, doing biomimicry in well-defined device with its non-biomimetic limitation is harder but rewarding topic. I felt like I'm renovating a house, which is sometimes be more expensive than building a new one. Nature care about sustainability and regeneration rather than reaching maximum efficiency, which is the language solar people talk. Every 1% costs millions of dollars. And the people connection and discussion in this community is what make it special. I really want to thank everyone here for their kindness and support. Thank you very much.
Thank you so much, Tayeb. Congratulations. Wow.
Thank you. Thank you.
I'd love to just congratulate you, Tayeb, and just express
Thank
how
you.
proud I am of your work and how much you've been able to kind of embody and incorporate what you've learned through the biomimicry program.